Hey guys, welcome to your virtual classroom. We are going to cover section 6.1, which is systems of equations and two variables. All it means to be a system of equations is that you are going to have more than one equation at a time, and you have to find a solution that will work for both of the equations simultaneously. There are three ways to solve systems of equations. The first method to solve a system of equations is the graphing approach. So when you do the graphing approach, you will graph each line and you will try to find the point where they cross each other. So for example, let's say I gave you the equations x minus y equals 5 and 2x plus y equals 1. And I asked you to solve the system of equation graphically. If you are going to do this, you need to be able to graph each line and find where they cross each other. So I'm going to put a picture of a grid in here for you. And we're going to use this to graph our lines. The first equation that you see, x minus y equals 5, is in standard form. The easiest way to graph when you are in standard form is to find your x and y intercept. To find your x-intercept, all you have to do is take the equation and zero out the y. And you would see that your line crosses the x-axis at 5. So you could plot that on your x-axis. To find your y-intercept, all you have to do is zero out your x. And you would find that your y is going to intersect at -5. Now remember that you want to draw a continuous line between the 2 points because you're never 100% sure where they're going to cross each other. Okay. Oh, I think I got off a little bit there. Let's try that again. 1, 2, 3, 4, -5. The numbers aren't in great spots. So we'll draw a nice continuous straight line between those 2 points. Okay? I would use a straight edge when you graph by hand. Now we're going to graph our second equation. You can do the same method if you want. You can find your intercepts. You could also just solve for y by subtracting the 2x to the other side of the equation. When you do that, you will see that you have a y-intercept of 1 and that your slope is -2. So that means you need to go down 2, right 1, down 2, right 1. And you should find the point of intersection. Your solution is going to be your point of intersection. Your solution does need to be written as an ordered pair. The x value is written first, and the y value is written second. Sometimes the graphing approach is not the best method because you'll have the lines intersect at a dot that's not an exact location. And so when you have that situation, you want to use method 2, which is the substitution method. I'm going to solve the exact same system we did previously using the substitution method. On the substitution method, I would write the equations next to each other. X minus y equals 5. 2x plus y equals 1. And then you have to choose one of the equations to work with, and you need to solve for one of the variables. It does not matter which equation, and it does not matter which variable. I am going to choose equation 1. I think it looks easier. And I'm going to choose to get the x alone. So I can get the x alone by adding y to both sides of the equation. And so that will update my equation to x equals 5 plus y. Now what I'm going to do with that is I'm going to take that 5 plus y And I'm going to substitute it into my second equation for x, because that is what x equals. When you substitute in, make sure that you use a set of parentheses. You will need to distribute the 2. 2 times 5 is 10, and 2 times y is 2y. You will also need to combine like terms. Positive 2y and positive 1y make positive 3y. You will need to isolate your variable, so we'll subtract 10 from both sides. And we'll need to divide each side by 3. So we found the y value. Our y value should be a negative 3. We then need to substitute that back into the other equation so that we can find our x value. Our x value is positive 2. Now, it doesn't matter that you're using a new technique. You still need to write it as an ordered pair. If you do not write it as an ordered pair, the answer is not correct. Often they will ask you whether your solution is consistent or not. All it means to be consistent is that you have an answer. Since we do have a solution, we can call this system consistent. Since they gave us 2 different lines, we can also call this equation independent. Sometimes they'll give you the same equation twice, and if they do that, that would be considered a dependent system. The third method to solve a system of equations is called the elimination method, and this is actually my favorite method. In the elimination method, you do not want to write the equations next to each other, but you want to write the equations on top of each other. For example, 4x plus 3y equals 11, negative 5x plus 2y equals 15. Notice that the equations are lined up by like terms. The x's are on top of each other, the y's are on top of each other, and the constants are on top of each other. When you do the elimination method, your goal is to eliminate one of the variables. So you have to choose if you're going to multiply one equation or both equations. Your goal is to get opposite terms. I'm going to choose to eliminate the x's. So my x's are a positive 4x and a negative 5x. So I need to multiply both equations by a number so that the positive 4 and the negative 5 can turn into the same number. So I am going to multiply the top equation by 5 and the bottom equation by 4. That's going to turn the x's both into 20s, which is what I want. And I want them one to be a positive 20 and one to be a negative 20. Just make sure that when you do this, you multiply all 3 items. So I need to take 4x times 5, 3y times 5, and I need to take 11 times 5. I also need to multiply my bottom equation by 4. So I need to take negative 5x times 4, 2y times 4, and 15 times 4. Now that you have the 2 equations, now that you have opposite terms, I'm going to move this up. You are now going to add the 2 equations together. When you add the opposite terms, the positive 20 and the negative 20, the x's eliminate, which leaves you with just y's. When you add positive 15y and positive 8y, you get 23y. When you add 55 and 60, you get 115. And then you can solve the bottom equation for y. To undo the 23, you will need to divide each side of the equation by 23, and you will find that y is 5. Remember though, your answer is an ordered pair. Right now, all you know is the y value of the ordered pair. So now you need to find the x value of the ordered pair. So I'm going to use the equation we found before, negative 5x plus 2y equals 15. And I'm going to use the finding for y so that I can get my x value. So I just found that y was equal to 5. So I will substitute that into my equation. 2 times 5 is 10. I will subtract 10 from each side. And negative 5x equals 5. Divide each side by negative 5. And x is negative 1. So your solution to the system is negative 1, positive 5. If you were to graph this equation, they would cross at those 2 points, or at that 1 point. Because there is a solution, this is considered consistent, and because they gave you 2 different equations, this is considered dependent. Now, there are times where you can get odd solutions. For example, let's say I gave you the equation x minus 3y equals 1, negative 2x plus 6y equals 5. If you tried the elimination method, you would multiply the top equation by 2. When you multiply your top equation by 2, you would get 2x minus 6y equals positive 2. When you try to add the 2 equations together, the x's eliminate and the y's eliminate, leaving you 0 on the left-hand side. When you add 5 and 2 together, you get 7. Well, 0 does not equal 7. This is a false statement, which means there are no solutions to this problem. When there are no solutions, we call this solution inconsistent, meaning there is no solutions to the system. When something is inconsistent, that means the 2 lines never intersect each other. Because the lines are still different lines, we call this an independent system. If you were to graph the 2 lines would run parallel to each other and never cross. So if you notice that you're dealing with parallel lines, the solution will always be inconsistent. There's one more special case that I'm going to show you. Let's look at the system 2x plus 3y equals 6 and 4x plus 6y equals 12. If you were solving this with the elimination method, you would multiply the top equation by negative 2. If you multiply the top by negative 2, you would get negative 4x minus 6y equals negative 12. When you add the 2 equations together, 4x and negative 4x eliminate, 6y and negative 6y eliminate, leaving you with 0 on the left-hand side. 12 and negative 12 eliminate, leaving you with 0 on the right-hand side. When you get a 0 equals 0, this is a true statement, which means that there are infinite solutions. When you look at the graph of the 2 lines, all this suggests is that they've given you the same equation 2 times. So the graph of both equations would land directly on top of each other. So if I asked you how many places the 2 lines intersected, the lines would intersect in an infinite number of places. So if I asked if this was consistent or inconsistent, because there are solutions or there are locations of intersection, you would say that this is consistent. But because they gave you the same line twice, you would call this a dependent system. What's going to be a little frustrating is that's not going to be where the solution ends. They're still going to ask you to write it as an ordered pair, and they will list just a generic X as your ordered pair. You need to find the y that they are looking for. In order to complete the ordered pair, you need to take one of your equations and you need to solve for y. This will be the solution to your ordered pair. Your ordered pair, instead of xy, will be x, negative 2/3 x plus 2. So notice that your solution is dependent on x. That's why you use the name dependent. Last thing you're going to encounter in this section is story problems. I have 2 examples for you. The first example. In 2013, the United States spent $452 billion more on the military than China spent on their military. Together, the United States and China spent $828 billion. Find the amount spent on military in China and in the United States. When you read this problem, you have to be able to identify 2 equations. Whenever you see a total, that always represents a solution to one of the equations. So together, the United States and China spent $828 billion. Together means that you're adding the 2. So if you took the United States plus China and added their military expenses together, it would come out to be $828 billion. You need to find a second equation. The second equation is going to come from the first sentence. The United States spent $452 billion more than China. So the United States equals China plus $452 billion. This system is set up perfectly for the substitution method. You can take C plus 452 and substitute it in for the United States. You can combine like terms. 2C plus 452 equals 828. You need to deduct 452 from each side. And you need to divide each side by 2. So 376 divided by 2 is 188. So China spent $188 billion. Now you can use that 188 to find what the United States spent. The United States spent 188 plus an additional 452. So the United States spent $640 billion. Last example for this first section involves motion. Whenever you have an equation that involves motion, you need to remember the formula that the distance equals the rate times the time. An airplane flies the 3,000-mile distance from LA to New York with a tailwind in 5 hours. The return trip against the wind takes 6 hours. Find the speed of the plane in still air and the speed of the wind. So when you do this, you need to set up 2 scenarios. Distance equals rate times time for each scenario. Your first scenario is your trip from LA to New York. That was a 3,000-mile flight. That flight took 5 hours. You do not know how fast the plane can naturally go in still air, and you do not know how fast the wind is blowing. But you know that the wind is blowing at the tail, which increases the speed of the plane. So if the plane can fly p miles per hour, and the wind can blow w miles per hour, then together the plane will travel at p plus w miles per hour. You can write that as an equation as 3,000 equals 5 times p plus w. If you want to simplify your equation, you could divide each side by 5. And you'll have 600 equals p plus w. You need a second equation for the return trip home from New York to LA. This is still a 3,000-mile distance. This time it takes 6 hours. But this time the wind is blowing against the plane. So it's going to decrease the speed of the plane. You can write this as an equation. 3,000 equals 6 times p minus w. And again, if you divide each side by 6, that'll simplify your equation to be 500 equals p minus w. This system is most easily solved by using the elimination method. P plus w is 600. P minus w is 500. You already have opposite terms, so multiplication is not needed. So you can just add 1p plus 1p and get 2p. 600 plus 500 and get 1100. Divide each side by 2 and you will have the speed of the plane, which is 550 miles per hour. If you substitute that in to one of your equations, you can find the speed of the wind. That's a minus, sorry. The speed of the wind is 50. Okay, give your homework a try, and I'll talk to you soon.